Hi, my name is Ambrosio Vasco Torres da Costa, undergraduate in civil engineering at the Oscar Ribas University, and about to graduate in a master's degree in construction project management at the Queen's University Belfast. Guys, this is hopefully the first of many videos here on the YouTube channel regarding hydrology and flood risk management in the aftermath of flooding events that happened here in Angola. If you live here in Angola or if you have been listening to the news here, you are aware of what I'm talking about. This video is specifically, I bring the subject of hydrologic soil groups. They are related, they have a direct impact on rainstorm and flooding events as they show how the soil impacts on the amount of water that infiltrates and the amount of water that will convert into surface water runoff depending on the level of urban occupation, vegetation covering, and open land existence within the area of the study. This is so important in grid capacity because it increases the potential sustainability level of the drainage system as it resembles more the natural hydrologic cycle, which includes, as it is shown in the figure I am showing, rainstorm, infiltration, and evapotranspiration. Concepts that I will for sure address in future videos here on this channel. As it can be seen in the table I am presenting, the hydrologic soil groups are classified from the letter A to the letter E. But now it brings a question: where can this information be found? Where can you find this information about the hydrologic soil group of a particular place you are interested in? So I bring this study from Ross, CW, and other authors from 2018. It's called Global Hydrologic Soil Groups for Curve Number Based Runoff Modeling. This study you can find on the daac.ornl.gov website and also on the earthdata.nasa.gov, which is a website from NASA, National Aeronautics and Space Administration from the United States of America. Now, with the map and data of the hydrologic soil groups in hand, it allows the delimitation of the different hydrologic soil groups in our region, which in turn will allow us to retrieve or to find what are the different areas or the different dimensional areas for each of the hydrologic soil groups within the region of our interest. So with these different values, we then have to go and also delimitate the different types of soil occupation or of human activity or human occupation of the soil in our region, be it the natural condition of the soil or due to human activity. These different types of soil occupation or soil superficial covering or soil or region occupation will depend on if it's a rural region or if it's a urban region or suburban region, a residential zone, for instance, residential zone, a parking lot, streets. So for each of these different zones, there is of course different types of infiltration, the same way it happens with the different hydrologic soil groups. So then we'll have two sources of data coming from different places. We'll have the hydrologic soil groups, and we'll have the different occupations of the soil surface, so which, as I've explained, depend on human activity or natural state of the soil covering. So the information on this table, which corresponds to the different curve number resulting from the combination of the region used or the human activity or occupation of that region and the hydrologic soil group must then be matched with what we have in our map. So for that, almost any GIS software can be used for this delimitation. For instance, QGIS can do that. So after we do this delimitation, whereby each of region, each of area delimited will correspond to one curve number, we'll have then a table generated within QGIS or another GIS software, where we'll have different area ID for a different area delimited. Then by exporting this data, we can then associate each of area ID with different corresponding curve number or CN number according to the SCS method or Soil Conservation Service, now called USDA NRCS, meaning US Department of Agricultural Natural Resources Conservation Service. So we can then, after exporting this table from QGIS, we can then associate each area ID with its CN or curve number coefficient according to the Soil Conservation Service method, or SCS method. So of course there are other methods like the rational method, for instance, but here I mention the Soil Conservation Service. Well, the same way I could mention another method, but it's just to show how it works, and the same thing can be applied to other methods. So this is it, guys. The information I presented pretty much covers the objective for this video. So the link with the research I present in this video about the hydrologic soil groups can be found in the description of this video and in the first comment. In these places, you will also find the link with the soundtrack of this video and a link with the research where I get the slides I present in this video. That's it for now. Thank you all. Thank you for watching this YouTube video. I ask you to subscribe to this YouTube channel, to give a like on it, and to watch the next video on this channel. Thank you very much for your attention, and I expect to meet you next time. I love Angola. Thank you. See you next time.